Problem 26, page 142. Here we have two objects, M1 and M2, are connected by a light string. When we say light string, it means the tension on each side must be equal, okay? Um, okay, here we have a massless pulley and frictionless. We can add mass of the pulley equals to 0. Draw free body diagrams of both objects. If the inclined is frictionless, it means mu equal to 0. Okay, we don't have interaction between M2 and the plane. And if M1 equals to 2 and M2 equal to 6, the angle of the inclined plane equals to 55. First of all, we have to calculate the acceleration of the system and the tension of the string and the speed of each object after t equal 2 seconds after being released from rest. Okay, I want to explain clearly the problem. First of all, you have to know that the pulley is without mass, massless. So the tension here equals to the tension here, and the tension here equals to the tension here. Because the pulley is massless, so here we have the same tension to the right and to the left. So here M of the pulley equals to 0. We can say T1 equals to T2 equals to T. First of all. Second, we have a light let's say we have a inflexible chord. So A1 equal A2 equal to A, and V1 equal to V2 equal to V. Okay? We have the same V. We have the same A, the same V. And now the first question here, I have to draw the free body diagrams of M1 and M2. It means you have to put all the forces exerted on each object. On M1, we have the weight and the tension, okay? On M2, we have the weight. Be careful, the weight must be vertical, okay? I think it's all. The pulley is massless, so we don't have a weight on the pulley, and we don't have a reaction. Action and reaction. We don't have in the case of massless pulley. And here we have the reaction N on M2. Is the reaction from the table, from the inclined plane on the mass M2. here we have m1g, and here m2g. Okay, let me put all the components of m2g also. You know, for m2g, we have to put x and y. It's very important. X must be in the line of direction. Maybe the objects, maybe the system will move clockwise or anti-clockwise. I don't know. I consider that the system will move clockwise, and I calculate A. Okay, if A is positive, it's okay. If it's negative, so we keep the same value of A, but the direction will be opposite. I take the motion in the line of motion must be clockwise, so M2 will move, or this one will be the line of motion. Okay, and here we have Y. We can do the projection from M2 on X and on Y. Okay, we get the value of the components M2X and M2Y. Okay, so here we have MGX, and here we have MGY. The angle between MG and the x-axis must be equal to theta. I sent one video. I explained this point. You have to know, in all the cases of the inclined plane and the weight, mgx must equals to mg sine the angle of the inclined plane. It's very important, and you have one video explains this one in details. Okay, and mgy equals to mg cosine the angle of the inclined plane. Okay, here I think it's all. Now the question, I need to calculate the acceleration and the tension. As the last example, to calculate any problem about the pulley, about the two objects attached in like this, you have to apply Newton's law on M1 and M2 separated calculation. Okay, don't combine and don't take only one system. So before, I have to precise the positive and the negative direction. We consider that the motion is clockwise. So M1 goes up and M2 goes down. So this one must be the positive for M1, and this one must be the positive for M2. And the opposite is the negative. The opposite is the negative. Here we have negative and negative. Okay. In this case, plus minus, like here you get plus and minus. Okay. We do the calculation. We take first of all M1 summation of F. Okay, before, let me explain what are we doing. I want to calculate the acceleration. I have to calculate the two equations, I need to calculate the velocity also. When you calculate the acceleration and you have time by using Newton's law, you can come back to the kinematics equations. Okay, it's important. You can use the kinematics equations to find the velocity. So now I am using Newton's law just to calculate the acceleration. Okay, this is a combination between the kinematics and the dynamics. So here, for M1, the summation of F on M1, here we have M1G plus T equals to M1A. We have A here. I don't need to write AX, AY, okay? We have the same. Here, A equal AY. And on the right side, A equal AX, but AA, we have the same value, A. Okay, M1G in the negative direction, so minus M1G, T is in the positive direction, we can say plus T equal M1A. This is the first relation between T and A. Okay, we take M2. We have the summation of F on the object 2 equals to T. We have T, we have N2, we have MGX, MGY, MGX, MGY, and T. T, N, MGX, MGY equals to, okay, equals to M2A. Okay, A. We don't need to write AX, AY, A. Now, T is in the opposite direction, in the negative direction. So here we can write minus Ti, because here we have X and here we have Y. Okay, N2 in the positive J direction, MGX in the positive direction, MGY in the negative direction, it's down, equals to M2A. Okay, now I need to calculate T and A. So we take I, and A in the direction of I, okay? A equal AX here. Here, A equal AX. We can say A. So minus T plus M G X equal M2A. Okay? Look here. We have a motion in the X direction. So we have A. But in terms of Y direction here, like this, we don't have motion. For this, we don't have AY. We have only A in function of the line of motion. Okay, this is the equation 2. This is the equation 1. We don't need to calculate in function of J. Okay, equation 1 and 2, we have 2 unknowns and 2 values. Let me be careful here. No, it's okay. I want to substitute for the equation 1 minus m1 equals to 2 times 10 plus t equals to m1 times a. So t equals to 2a. We can say here t minus 2a equal to 20. Okay, this is the first equation. This is equation 1. We can say here it's equation 1. And here the same, we can say minus t, or we can put t on the other side. We can say m2a plus t equal mgx. mgx equal mg sine theta. Okay, equal mg. We are talking about m2. It means we have equal m2 g sine theta. So m2 equals to 6 times a 6a plus t equals to m2 equal 6 times 10 times sine 55. This is equation 2. By your calculator, you have to solve equation 1 and 2. You have 2 equations and 2 unknowns. You can calculate easily a and t, okay, which is equal to, we get a equals to 3.57 m per second square and t equals to 26.7 Newton. Okay, we have a and t. Now we have to calculate the velocity v of the speed as magnitude. To calculate v, you have to come back to the kinematics equations. You know, we have v final minus v initial equal at. Here we don't have ax, ay. It's the same, okay? On the x-axis. On the x-axis, you can say vx or v. Doesn't change. We have only one dimension on the x-axis. I'm talking about m2. M2 is moving along x-axis. So v equal vx. You know, the object was at rest. In this case, v initial equal to O, because at rest. The final v at t equal 2 seconds, we can say here equal a times a equal 3.557 times t equal 2 seconds, we get the final value equal 7.14 m per second. Okay, I advise you to solve this problem with all the calculations. It's very important. You must have the final answer. You have to put the units. I advise you to go ahead to the end of the problem, because you have some notes for the units for the answer. Thank you.